Hey, how's everybody doing? Welcome back to Math for Healthcare, the video lecture series. Today we're going to do a linear regression example and kind of go through and discuss some ideas that we've seen in the previous linear regression videos. So here, what we're looking at in Desmos, I entered data that's the x values is years experience and the y values is the salary in thousands of dollars. Okay. Now, I think it's wise and worthwhile to write down I call this defining your variables, and it includes the units. So we know what we're working with, and we could use it to analyze. Now, so for instance, here, the first data point, 360, means someone with 3 years experience is making $60,000. All right. So the first thing we want to do when we're considering this, and we're going to, maybe think about, okay, can we come up with a function to place people? Well, there's some things to think about. A linear function. First thing we want to do is make a scatter plot, enter into a table here in Desmos, and look at our scatter plot. Here, by the way, is, when you enter data, this little zoom fit thing, if you click on that, it zooms into your data from that table. Okay? Now, this looks like it could be reasonable for an estimate to use linear regression. We do have a little bit of a cluster down around y equal to 60, the 60,000 range mark. But taken with those upper ends, it looks like we could reasonably fit a line to it. So we'll go ahead and we perform linear regression. So we enter y1 tilde m times x1 plus b. And that will give us the line. Okay. Now, and of course it also gives us the slope of 10.386 and the y-intercept of 23.7. All right. So, suppose, now think about, are we still happy with the fit? What would we need to check for that? Well, a good idea, the first place we go is our R, our correlation coefficient R, which is 0.91. And I would call that a moderately strong positive linear correlation, because we're talking about it with respect to linearity. R squared is 0.84-ish. And similarly, we can't see that it's positive, but it tells us that it's a moderately strong linear correlation. I think for this application, I'd probably be willing to accept that R squared value. Remember, there's no set rule. It really depends on what you're doing. But here, I think it's fairly reasonable. And remember what that R squared means. It means about 84% of the variability in the Y values is taken into account by the variability in the X values, or the different years' experience. Okay. Now, let's suppose now we want, you've done this regression, and let's say someone gets hired with, say, 12 years experience. All right, so how would we go about that? Well, the first thing I would do is I like to enter manually my linear regression line as a linear function here. For salary, I put S of X equals M, because it's using this whole M here, times X plus B. All right, and that line will go over your regression line. And then check. Okay, so now I could just plug it in. I plug in 12, and I end up with 148.3487, so on. And that tells me that my regression line predicts that someone with someone with 12 years experience should have a salary of about $148,400, whatever you want to call that. Right? And don't forget that because this isn't thousands of dollars, 0.3 is, you want to keep that. That's $300, right? That's not just 0.3. It's not 30 cents, so to speak. All right. So now we ask and that's thousands of dollars to 12 is in years experience. So I guess something that we should look at here is what about the slope of this line? All right. Well, the slope equals 10.39-ish. I'm just going to write down for now. If we want to interpret the slope in the context of the problem, we want to write down the units. And remember, the units of the y, or the slope is the change in y over the change in x. So the units of the slope are here is thousands of dollars per year experience. And when we want to interpret that, we're going to think of 10.39 over 1, okay? And so this tells us that for each increase in years experience, your salary should increase by about $10.39 thousand. Right? Now, so the thing is you come up, you plug in the 12, and you get $148,000-ish, right? But then someone says, well, actually, there was a data point missing, and someone at the company makes that with 12 years experience makes $122,000. All right, so to give us an example here, or the visual is T there. That's the point of the real salary, and our predicted one is straight up from that hits the line. I'll enter that. That was 12, and I'm just going to put S of 12. Okay. So I see that point up there. And there it is. That's our predicted value. Okay, so they're a good bit off. And you may say, well, I would ask you does this surprise you? And I want you to think about it for a minute, maybe hit pause on the video, and think about reasons that this would happen. And when I say reasons, I want you to think about the mathematical reasons, not necessarily what other things are going on. Because obviously, your salary should be, there's other things besides years' experience, right? But here we're just looking at your years' experience. And I want you to think about how can that go wrong? I mean, we had a pretty decent R value, but somehow all the way out here, it's looking like it's way off. So, what's going on? Well, this is what's called extrapolation. Notice in our original data set, the years experience range from, what is it, about 3 to 7. 3 to 7 years. Okay? Now, that correlation coefficient really only tells you how well the data is going to fit near that range. Look what we're trying to do. We're trying to take data from the 3 to 7 range, all right? So what's that? That's a length of about 4. And then we're wanted to, from there, predict with what happens at the 12 years experience. So what? 12 is 5 more than 7. So you're going 100% past your range of collected data values. And that is always a dangerous thing to do. And that's why you could see this calculation here. And why may that happen? Maybe your later years experience, you're starting to see a top out by how much more money you make by then. But mathematically, why is it happening? This is extrapolation at work. Now, so we got to be very careful about predicting past our data, whether that means trying to predict into the future and really I should say too far past our data. Because we're always assuming trends continue. The further on you get past your data points, the more likely that the trend will not continue. So here, now, last thing I'd like to do is, how will our regression line change if we added in the data point 12, 122? Will the slope increase or decrease? And and let's see here. Go ahead and plug that in. 12 and 22. Whoops, that's why. I watch those typos. 122. Okay, so now notice my other point fixed. My M decreased, which would make sense because that 1222 pulled the line down a little bit. All right, and let's see here. It looks like the R and the R squared increased by a little bit. But, and then notice our prediction then for 12 years experience is now 128,000 and much closer to what the actual value is. All right, thanks for listening, and I'll see you in the next video.